Today's lesson, lesson 1.3, modeling quantities. Our objective here is we're going to use proportional reasoning and analyze units when solving problems. So I have a couple different vocabulary words. You may recognize them, you may not. That's okay. We're going to go over each of them, and then we'll write down an example of each as well. So start off, a ratio is a comparison of two quantities. So for example, we could compare the number of boys to the number of girls in our class. And we can represent a ratio with dots. You may have seen that back in middle school. I know that's how I introduced it to my sixth graders when I taught sixth grade, okay? You can also just say like the words, like how I said, boys to girls, okay? Or we can even represent these like a fraction like we kind of did the other day with our speed, how is miles per hour or meters per second. We can have, if we're comparing boys to girls or the number of boys to girls, we can have the number of boys on top in a numerator and the number of girls in the denominator, all right? So 3 different ways to represent it. Usually the way we represent it is this way, okay? I will tend to write them as a fraction, hence why we have proportions, because they all kind of interrelate, all right? That gets me on to my next thing, proportion. An equation stating 2 ratios are equivalent. So for example, I could have a proportion of 12 over 8 is equal to 2 over x. That's a proportion. And we can apply units. We'll do some without units, and we'll have some in word problems, okay? Right now, we just have basic straight-up numbers. The last one is a rate, a ratio of 2 quantities using different units. You can write rates in many ways. We saw rates the other day. We had, for example, you see probably 55 miles per hour, right? You can write it as 55 MI to represent miles over 1 HR for hours. Or you could represent it as 55 MI slash HR. Sorry, my H is kind of on the line there. Depending on how we're using it, I will choose a different representation. We're going to start with solving the following proportions. So we have 1 through 6 have solving proportion, and we're going to show all of our work. Have you guys remember seeing proportions ever? Okay, that's okay. We're going to do them today, all right? So it's pretty much, it's a fraction equal to a fraction if you think about it, all right? Have you guys done fractions that were equivalent, like way back when, like 1/2 is equal to 5 over 10? Have you guys remembered that? Those are proportions. Sometimes we just are going to see ones that aren't as pretty or easy to see, okay? And that's where this method comes in handy, when it's not something we could just do in our head and it's something small or easy like 1/2 is 5 over 10. 1/2 is 3 over 6. 1/2 is equal to 4 over 8. Those ones we kind of know in our head, all right? There's not always going to be that clean, easy time in math. Sometimes math is messy. So we have formulas and steps to do it. When it is messy, it's not impossible. You can still do it. All right, you just have to follow a method. So we'll start with some easier ones, okay? And I like to start with the easy ones so we already know kind of what our answer should be or close to it. But we're going to practice the method for if it is more complex. When it does give us something uglier that's not a whole number, we can still do it because we have this method in our pocket, all right? So looking at this first guy, I have x over 4 equals 9 over 12. What we do, anytime we're solving proportions, there's this magical rule in math. Somebody was like, hey, these have to be related somehow. And somebody decided, okay, I'm going to multiply my diagonals. All right, so see how x is on the top on the left and 12 is on the bottom on the right? That is diagonal from each other. They said, okay, what if I multiply those together? So I'm going to multiply 12 times x. And I multiply the other diagonal, 4 and 9. How do they relate to each other? And so what they found was when they actually multiplied those diagonals, they were able to find the missing piece. And so they found that they call it cross products because it's cross and products mean multiply, okay? They said cross products are equal to each other. So anytime you had a proportion, you can use this method. You can do your cross products and set them equal. Well, 12x, I don't know what x is, so we'll pause there. What about 4 times 9? Do we know that? 36. So now we have 12x equals 36. We can solve this. This is a linear equation that we've done now since the beginning of the year. How do I get x by itself? Yes, awesome. Divide by 12, and now we have x equals what? 3, yes. Okay, 3/4 is equivalent to 9/12. Okay, I can check it over here. I'm just going to write it over here real quick. 3/4 is equivalent to 9/12. It's saying that, hey, they may look different, but they're equal. We can check it in our calculators. Do 3 divided by 4. What decimal do you get?
0.75.
Yes. Do 9 divided by 12. What decimal do you get?
0.75.
Okay. They equal the same thing. You may have seen it in the past where when you were doing this and learning this, you said, oh, if I multiply 3 by 3, that gets me 9. If I multiply 4 by 3, that gets me 12. So all of this stuff that you learned in the past, we're kind of bringing it here and applying it, okay? That's all that proportions are. They're just equivalent fractions. We just have to figure out what's missing, okay? Let's try another. Let's do number 2. Actually, I want to go to number 3. Sorry. We'll do number 2 in a second, but we'll do number 3. I like the negative thrown in here. Negative 11 over 5 is equal to x over 10. All right. Remember, my negative sometimes is written just hanging out. Okay? Am I allowed to float it up to the 11? Yeah. And can I float it down to the 5 if I wanted to? Yes. Can I give it to both of them? No. Okay? Wherever you want to float it, choose where you want to float it. I always float it. I think of it like a balloon, so I always float it to the top. So I'm just going to rewrite mine as negative 11 over 5 equals x over 10. And so we're going to do our cross products again. Okay, cross product, negative 11 times 10, what do we get? Yeah, negative 110. Then we do the cross products of the other diagonal. And we say it's equal to 5x. Now let's solve for our x. What do we have to do? Yes, awesome. Divide by 5. Purpose of dividing by 5 is to get 1x. That's our goal. So now I have 1x on the right side. What's negative 110 divided by 5? Negative 20 what? 2. Thank you. Negative 22. And again, if I were to plug that back in, if I could check, negative 22 divided by 10 should be the same decimal as negative 11 divided by 5. Okay? So a quick way to check. Let's just keep going with the odds. Let's do 6 over y is equal to 2 over 5. Try and keep that guy in the picture if you need. All right, do your cross products again. And technically, sorry, I always tend to go the top left to the bottom right. Does it technically matter which cross product I do first? No, not at all, okay? As long as I'm doing the diagonals and multiplying them together, it doesn't really matter which one I multiply first. So 6 times 5 is 30, right? And then we have 2 times y is 2y. And then, so what would y be, guys? 15. Awesome. How'd you get 15? Yay! We divided by 2. Awesome, because we had to get the y to be just a 1y. That's why we divided by 2, and we have to do it to both sides to keep that equation balanced. Anytime you have an equation, it is a scale. Think of it like a scale, a weight. That you're weighing 2 different things. They have to always be equal. Awesome. Let's do, let's go to word problems. We may come back to these 2, 4, 6. Let's go to the word problems. Okay? So everybody always gets scared with words. Words are not scary. Just break them down like we did the other day. Okay? So we did proportions where they give us the proportion. We're going to do some word problems where they still give us the proportion, but it's kind of hidden within the words, all right? So they say you take measurements shown in the diagram. Here's our diagram. The right triangles created by each object and its shadow are similar. So later on, you'll talk a little bit more about how right triangles are similar and what that means. In the past, you've learned about triangles, right triangles. What kind of angle does a right triangle have? 90 degree, okay? When they are similar, bless you, when they're similar, it's as if I had this triangle and I zoomed in and made it bigger. That's what similar means. Like all of the proportions with all of its sides are the same. They're equivalent fractions. And so anytime they're giving you right angle or right triangles that are similar, we can actually set up a proportion to solve anything that we're missing. So that's what we're going to do. That's why we're going to use a proportion on this. They want to know can the tree fall onto the house? So I'm going to zoom in on my diagram because I need to know a little bit more context, okay? All right, so we have the tree. I can see the tree right here. Got it. Do we know how tall the tree is? No. So let's put an X for how tall it is, okay? And if you need to write it outside the tree leaves so we can see it a little bit better. But we don't know how tall that tree is, okay? So I'm going to try and make a thick line there. Sorry. Probably should use a different color. There we go. Yellow. Yellow shows up better. Okay. So I don't know how tall it is. Do we know the shadow? Yeah, the shadow is 30 feet. They say it right here. Awesome. They go from that very tree to the tip of the shadow. All right, what else is in the diagram? How tall a person is, right? The person's right here. How tall is that person? How big is their shadow? 8 feet. Okay, so I use the 6 feet, I use the 8 feet, I use the 30 feet. What is this 25 feet? Why did they give that to me? Yes, how far the house is, the space between the tree and the house. If the tree is 20 feet high, is it going to hit the house? No, because it's 25 feet away. If the tree is 30 feet tall, will it hit the house? So we needed that last bit, not to use in our proportion, but once we know how tall the tree is, to figure out, okay, can it hit or can it not hit, okay? So what we're going to use for the proportion is the person's height, 6 feet, the person's shadow, the tree's height, and the tree's shadow. So whatever we do, whatever we decide to put on top for our proportion for the person, we'll start with the person. That's what we have to put up top for our tree. So let's do the height for the person. So the 6 is going to go in our numerator, okay? And we could put person equals tree. How's that? That way we know that the left side's all the person stuff and the right side's all the tree stuff. So how tall is the tree? Do we know? No. What are we going to put? Bingo. Perfect. Okay, so that's how tall the person is. So I already used 6 feet. What about their shadow? 8 feet. So that's what goes on the bottom. And we're going to do the shadow for the tree. What's the shadow for the tree? 30 feet. Now we have our proportions set up. Now we can solve it just like we did with those 3 on the front. Do your cross products. I'm going to do 8x first since I tend to do the top. Because my cross products are still always equal to each other because these are proportions. What's 6 times 30? 180. Awesome. Can I solve for x now? Yeah, what do we do? Yep, by 2? 8. Awesome. Divide by 8. So how tall is that tree then? 22.5 feet. Awesome. So, can it hit? Nope. Awesome. So can the tree fall on the house? No, it cannot. Okay? And I'm going to box it right by the question so I remember, did I answer the question? Yes, I did. Now, we've dealt where units are not always the same. I think it was 2 lessons ago, right? We had to make sure that our days, right? We had like hours and days, these 2 different measurements. And so we had to make 9 days into hours. Well, it's not every person is like just 6 feet tall even, right? We have inches involved. So the next one has something else, okay? Very similar. And they don't give us a picture. They're describing it in words this time. It says, your friend is 5 feet 8 inches tall and casts a shadow of 12 feet long, okay? At the same time, a nearby tree casts a shadow 54 feet long. A drone is stuck at the top of the tree. Can you use a ladder that allows you to reach a height of 21 feet to retrieve the drone? So, if my ladder maxes out at 21 feet and the drone is 25 feet up, can I reach it? No. If the drone is 15 feet up, can I reach it with that ladder? Yes. So do I necessarily need the 21-foot ladder in my proportion? No, it's similar to the 25 feet away from the house. It's just there to answer that final question. But we don't include it in the proportion because it's not the height of the person and it's not the height of the tree. It's not their shadow or the tree shadow. Okay, so let's set it up the same way. We have a person and we have a tree. Okay, so my person, how tall again were they? 5 foot 8 inches. Now, I got 2 units of measurement going on there, okay? I have a couple choices. I can, if I know how many inches are in a foot, I could technically make this a decimal and do it that way. I could decide if I know how many inches are in a foot, I can convert it all to just inches and just do a larger number all in inches and then convert it back to feet later. It's really however way you want to do it, okay? I'm going to just convert it all to inches because I don't really want to deal with a fraction or a decimal piece, okay? So how many inches are in a foot? 12, okay. So I know 8 inches. So if I have 5 feet and every foot is 12 inches, 60, yes. And 60 plus 8 would be 68. So our person is 68 inches tall. Okay? Again, recap. We did 5 times 12. That's how we got 60. And then we added 8 to that. And that's where we got the 68. Okay? Now, if I make that inches, what do you think I have to do with their shadow? Inches. So similar, right? What are we going to multiply 12 feet by? 12. And what does that give us? 144? Yep. 144 inches. Okay, that's the person. That was their shadow. That was their height. Now we do the tree. Do we know? We don't know the height of the tree, right? X. Let's do it. I prefer using X. Okay. What about their shadow? What are we going to do with that guy? Ooh, 54 feet long. What are we still multiplying it by? 12. Yes. Times 12. Right? What do we get? 640 what? 8. Thank you. 648 inches. It is really important that you can't have different units, okay? So whatever you choose to do, just make sure you do it for all of them, okay? And again, we could have chose to make this a decimal. It's okay. We'll all get the same answer in the end because I'll convert it back to feet in the end. All right, let's do this. Cross multiply. 68 times 648. Anytime I run out of room, I draw an arrow going to where my next step is, okay? That way, it makes it easier for me to look back and follow. If I'm grading your stuff, it makes it easier for me to know where you went next, and that way I can see, okay, they did this right, or, oh, we need to rethink it. Fairly large number, right? Make sure you guys are checking with your neighbors. Did you guys all get that? 44,064, okay? And then I have 144, X for my other diagonal. Awesome. Then what did we divide by? 144. And what do we get there? 306. Good. But that's in inches, right? Can we convert that back to feet? Yes, divided by 12. Remember, to get to inches, we multiply by 12. So to undo it, divide by 12. Excellent. Okay, when we divide this guy by 12 to get it back into feet, what do you guys get? 25. What is it? 25.5 feet. Okay. So can the ladder reach? No, it's too short. Nope. The ladder can't reach. All right. So that was our piece of proportions. We're going to kind of talk about rates a little bit, okay? Now, the diagram below shows statistics for a baseball pitcher. Use rates to compare the pitcher's performance in 2019 to his performance in 2020. So I'm going to zoom in on this guy here, okay? We have innings, we have hits, so and this is a pitcher, so he pitched 70 innings. They got 54 hits off of that. Earned runs were 19. Walks, he walked 29. And strikeouts, he had 100. Okay? And then in 2020, same thing. Innings, hits, earned runs, walks, strikeouts. So there are lots. There's 5 different things that they are measuring. So there are technically like 5 different things that we can kind of compare and use a rate to analyze how he did. These are just 2 methods that you can use. So I could choose to do strikes per walk or runs per inning. Neither one is incorrect or correct. It's just taking, remember, rates are just comparing 2 things, okay? So I can compare my strikes, my strikeouts with the number of walks he let, okay? I could do runs per inning, okay? He let 19 runs here in 70 innings. He let 15 runs here out of 50 innings. I can choose different things to compare. There's no right or wrong here, all right? As long as it's here, you can't make something up. It's not on the diagram. That's about it. So we're going to pick one. Do you guys want method 1 or 2 today? 2? I heard a 2 first, sorry. We're going 2. All right, runs per inning. So 2019, I'm looking at my earned runs. Here we go. Yep, we have 19, and then they said per inning. So these are the 2 that we're going to compare. I kind of circled them there. There we go. There we go. So we have 19 runs over 70 innings. And then in 2020, we had 15 runs over 50 innings. Now, it's hard to compare them this way, but we can, the number part, I can divide. Go ahead and divide 19 divided by 70, and let's go to the nearest hundredth. So 2 numbers after your decimal. That's what I want you to round to. And compare with your neighbor. Make sure you guys have the same answer, okay? And then we'll talk about it. Okay. So 2019, did you guys get 0.27 when you rounded it? Awesome. What was the number after? What was the third number? 1. Okay, perfect. So that's why it stayed. Yes. So 0.27 runs per inning, because those don't cancel out. They're 2 different units, so it's not like they cancel out and they're gone. It still runs per inning. I wrote it with a slash. And then what about the 15 divided by 50? 0.3. Yeah. And there was a 0, but do I have to put a 0? No. Did I still round it technically? Yeah. Okay. If you want to put the 0, you can, but you don't have to. All right. So what would be a better, if we're talking about it, it says the pitcher had blank earned runs per inning in 2019. So did he have more runs or less runs? Less, yeah. 0.27 is less than 0.3. Because remember, 0.3 is really like 0.30. Good. So you could say he had less earned runs or he had fewer earned runs, whichever. So is that good for a pitcher, that he gave away less or more? Less is better, right, for a pitcher? I know. I have to think about it, too. I asked my baseball people. That's right? Okay, flip to the next page. We have some conversions. Up here, we have useful conversion rates. I have put on, so I know we're not going to use them all in here, but these also are on your homework. You will need to reference these to be able to convert some of your problems from your homework, okay? So we're going to start with this first one. It says 5.3 yards to inches. They want us to convert it and round to the nearest hundredth if necessary. Sometimes we don't need to round. So we write 5.3. Yards are abbreviated as YD. Anytime I'm converting, what I'm going to do is I'm going to multiply it by what they call the conversion rate. Remember, rate is just kind of that fraction looking piece. So I'm going to times, and I'm going to find it up here in my conversion. I want yards to inches, so I'm looking for yards to inches. Nope. Yards to inches. Nope. Oh, here it is. Yards to inches right here. I'm going to highlight mine just so you can see what I'm looking at. You don't have to because you're going to use a couple of these, okay? If you want to, you can write it down here. Yards, 1 yard equals 36 inches. That way you know where we got this from. So this is our conversion rate. Now which one do we write on top? Which one do we write on bottom, right? A rate is represented like a fraction. Here's how you know. If this is yards, then when I write my conversion rate, I'm putting that yard on the bottom. So 1 yard goes on the bottom. That means my 36 inches go on top. Here's why that is set up the way it is. Remember how we talked about a number being divided by itself? So say 2 divided by 2. What does that give us? 1. And we crossed it out, right? When we were solving problems. Guess what? Yards over yards, guess what's going to happen to them? They're going to cancel out, just like our 1 over 1 or our 2 over 2. So that is why we have to put the yards on bottom in order to get rid of it and not have it anymore. Now I just multiply straight across. When you're multiplying whole number, it's like you have a denominator of 1, and you just multiply the top with the top and the bottom with the bottom. So we do 5.3 times 36 inches. On the bottom, it's just 1 times 1, which gives me
190.8.
Nice. Oh, not 0.8 though. Should be, try again.
No, it is. That's not 0.8.
Oh, is it? Let me see.
Wait, which one are we using?
Oh. Yes, sorry. 190.8. Thank you. I had it in here wrong. Okay. I have inches still, right? That's my measurement. Do I have to put it over 1? No, we don't write whole numbers over 1. So that's it. It's 190.8 inches. All right, let's do 0.6 kilograms to milligrams. Same idea. I start with the 0.6 kg for kilograms, and I'm going to multiply it by the conversion rate. I have to find kilograms to milligrams. So I'm going to go up here, right? What do we have? Yeah, so 1 kilogram is equal to 1, 2, 3, 4, 5, 6. There we go. I have to count out my zeros because sometimes I'll miss them when there's so many. Okay? Is equal to a million milligrams. That's our conversion rate. So I put the 1 kilogram on the bottom because I need to be able to cancel them out. And I put the million on top. 1, 2, 3, 4, 5, 6 mg. The kg cancels, and I multiply 0.6 times a million. Yep, 600,000.
Yeah.
All right. And then don't forget your milligram, your mg at the end. And again, the bottom just became 1, so I didn't have anything left over to write underneath it anymore. It was just a whole number. Sometimes you're not going to have just one conversion rate that you need. That's okay too. We're going to do 12 and 13 have more than one conversion rate, but it still gets us to where we need to go in the end. So I have 4.8 gallons, abbreviated GAL, to fluid ounces, abbreviated as FL, and then OZ, okay, fluid ounces. Now on my conversion rate, if we're looking at the very top, okay, I see 1 gallon can equal 16 cups, but that's not fluid ounces, right? But then look at the one underneath it. It says 1 cup is equal to 8 fluid ounces. Sometimes they're not going to give you just the conversion you need. You may need to do one conversion and then another one to get to our final kind of solution there. That's okay. As long as we locate what we need and we're still getting from gallons to fluid ounces, we're good. And we're going to do the same process. So I start with 4.8 gallons. I'm going to multiply it by the conversion rate, the 1 gallon to 16 cups. Is 1 gallon going on the top or the bottom of that rate? Careful. I heard top and I heard bottom. Bottom. Okay, there we go. 1 gallon. Because remember, I need these to cancel out. And the only way they will is if they're diagonal from each other, okay? 1 on top, 1 on bottom. That means that my 16 cups goes on top. Now, I could do this and get an answer for cups and then do another conversion. Or I could do it all at once. It is your preference, okay? I don't care which one you do. They'll both get us the right answer. If doing one and solving it and getting cups and then doing another one is easier to stay organized, then do it that way. If you're like, no, I'm good, I could just do this in a string, then do it that way. I don't care which, okay? I'm going to do it where it's in a string. So I'm going to times it again by another conversion rate. All right? This time, I'm going to use my 1 cup and my 8 fluid ounces. Now remember, cups is up top. So where am I going to put the 1 cup? Top or bottom? It's got to cancel. Bottom. Okay? Because look, we have cup here, cup here. 1 top, 1 bottom. That's the only way we're able to cancel them out. And then my 8 fluid ounces will go on top. Okay, so we have a lot of canceling out to do. My gallon canceled out with gallon. My cup canceled out with cup. So in the end, I only have fluid ounces is what I wanted, okay? And now remember, I just multiply everything on top and I multiply everything on bottom. The only thing is on bottom is what? What number? 1. Do I have to put it over 1? No, so really, I just have to multiply the top. So do 4.8 times 16 times 8, hit enter. Yep, 600, what was it? 614.4. Awesome, fluid ounces. Okay? You would have gotten the same exact thing if you did it 2 separate conversions as well. All right? Let's do our meters to inches. So we have 2.5 meters times, and we're looking for meters to inches. I don't know if we're going to have it, though. Let's see. I have meters to centimeters. I have meters to millimeters. Okay, I see it. I'm going to scoot it up right here. Do you guys see this guy here? 1 meter to centimeters, and then right next to it, do you see this 1 centimeter to inches? Sometimes the conversion is a decimal, okay? I know for a fact that you have a homework problem like this that requires that messy decimal, okay? Don't round it too soon. That's my only little hint, okay? All right, let's use that then. So we have, let's see, what do we say? 1 meter equals 100 centimeters. And then I'm going to use 1 centimeter is equal to 0.393701 inches. Okay, those are the 2 that we're using from the very top. Since I did it all at once on the last one, I'm going to break it up this time on this one. You can still do it all at once. We'll get the same answer, okay? So you don't have to copy my method. I'm just going to show you both. So this first one, I need my meters. So I have 1 meter. Does that go on top or bottom again? Bottom, good. And then my 100 centimeters goes on top. So I'm going to calculate this one first, and I'll see what I get. My meters cancel out. 2.5 times 100, what do we get there?
250.
Good, 250, and now I have centimeters there. Now, I'm not done because they want me to get to inches, but now I can use that answer, that 250 centimeters, and I can go ahead and multiply that by the other conversion rate we were using. So 1 centimeter goes on the bottom, and then that crazy decimal goes up top. 393,701. Okay? Oh, and I almost forgot my IN for inches. Centimeters cancel. That's the only way they're going to cancel out. We need them diagonal from each other when we're multiplying. And then I multiply 250 times this long decimal, then round that answer to 2 decimal places if you need to. Did we need to round that guy? I feel like that was a rounding one maybe. Yeah? No?
Yes.
Okay. What do you guys get?
2,
Oop.
5,
Oops.
98.43.
4-3. What was the third number there?
5.
A 5. So was it 0.425 and then we rounded it up? Awesome. And then don't forget your inches. Okay? Remember the next page you have for scrap, so either use this or use your notebook, okay, for your homework. And we'll stop here.